Hi, my name is Ashish and I welcome to you in the second video in the principles of cloud computing for the cloud deployment model. So this is, as I told you, after going through the series of videos, you will be able to clear the AZ900, but you'll have to go through some of the content yourself. This video series will give you the basic idea on how to cover in the topics related to AZ900 exam. So to start with, we have the cloud deployment model. So there are three different cloud deployment models. A cloud deployment model defines where your data is stored and how your customers interact with it. How do they get to it and where do the applications run? It also depends on how much of your own infrastructure you want or need to manage. We have public cloud, private cloud, and the hybrid cloud. Public cloud. This is the most common deployment model. In this case, you have no local hardware to manage or keep up to date. Everything runs on the cloud provider's hardware. In some cases, you can save additional cost by sharing computing resources with other cloud users. Businesses can use multiple public cloud providers of varying scale. Microsoft Azure is an example of a public cloud provider. Advantages: high scalability, agility. You don't have to buy a new server in order to scale. Pay-as-you-go pricing. You only pay for what you use. You're not responsible for maintenance or updates of the hardware. Minimal technical knowledge to set up and use. You can leverage the skills and expertise of the cloud provider to ensure workloads are secure, safe, and highly available. A common use case scenario is deploying a web application or a blog site on the hardware and resources that are owned by a cloud provider. Using a public cloud in this scenario allows cloud users to get their websites or blog up quickly and then focus on maintaining the site without having to worry about purchasing, managing, or maintaining the hardware on which it runs. The disadvantages. Not all scenarios fit to the public cloud. Here are some disadvantages. There may be specific security requirements that cannot be met. There may be government policies, industry standards, or legal requirements which public clouds cannot meet. You don't own the hardware or services and cannot manage them as you may want to. Unique business requirements such as having to maintain a legacy application might be hard to meet. Now we have the private cloud. In a private cloud, you create a cloud environment in your own data center and provide self-service access to compute resources to the users. This offers a simulation of a public cloud to your user, but you remain completely responsible for the purchase and maintenance of the hardware and software services you provide. Advantages. This approach has several advantages. You can ensure the configuration can support any scenario or legacy application. You have control and responsibility over security. Private clouds can meet strict security, compliance, or legal requirements. The disadvantages: you have some initial capex cost and must purchase the hardware for the startup and maintenance. Owning the equipment limits the agility to scale. You must buy, install, and set up the new hardware. Private clouds require IT skills and expertise that's hard to come by. The use case scenario for a private cloud would be when an organization has data that cannot be put into the public cloud, perhaps for legal reasons. An example scenario may be where government policy requires specific data to be kept in country or privately. A private cloud can provide cloud functionality to external customers as well, or to specific internal departments such as accounting or human resources. Then we have hybrid cloud. Hybrid cloud combines public and private clouds, allowing you to run your application in the most appropriate location. For example, you could host a website in the public cloud and link it to a highly secure database hosted in your private cloud or on the on-premises data center. This is helpful when you have some things that cannot be put in the cloud, maybe for legal reasons. You may have some specific pieces of data that cannot be exposed publicly, maybe the medical data, or you are the government army data, which needs to be held in your private data center. Another example is one or more applications that run on old hardware that can be updated. In this case, you can keep the old system running locally and connect it to the public cloud for the authentication, authorization, or the storage. Advantages. Some advantages of a hybrid cloud are: you can keep any systems running and accessible that use out-of-date hardware or an out-of-date operating system. You have flexibility with what you run locally versus in the cloud. You can take advantage of economies of scale from public cloud providers for services and resources where it's cheaper, and then supplement with your own equipment when it's not. You can use your own equipment to meet security, compliance, or legacy scenarios where you need to completely control the environment. Disadvantages. Some concerns you'll need to watch out for are it can be more expensive than selecting one deployment model since it involves some capex cost upfront. It can be more complicated to set up and manage. Summary. Cloud computing is flexible, gives you the ability to choose how you want to deploy it. The cloud deployment model you choose depends upon the budget, security, scalability, and maintenance needs. So after covering the different cloud deployment models, we have cloud services as well. So we have infrastructure as a service, which is IaaS. We have platform as a service, which is PaaS. We have software as a service, which we pronounce as SaaS. So what is IaaS, or infrastructure as a service? Infrastructure as a service is the most flexible category of cloud services. It aims to give you complete control over the hardware that runs your application. IT infrastructure, servers, virtual machines, storage, networks, and operating systems. Instead of buying hardware with IaaS, you rent it. It's an instant computing infrastructure provisioned and managed over the internet. So you create a virtual machine, then you would be able to access it through the public internet. You will have the public IP address associated with it. I'll show you later how you create a virtual machine and how you connect to it. So when using infrastructure as a service, ensuring that a service is up and running is a shared responsibility. The cloud provider is responsible for ensuring the cloud infrastructure is functioning correctly. The cloud customer is responsible for ensuring the service they are using is configured correctly. So if you have not configured the machine correctly, if you have not configured the networking correctly, you will not be able to connect. But the machine would be up there. That is the responsibility of the cloud provider. So the infrastructure as service is commonly used in the following scenarios. You are migrating workloads. So when you are migrating the on-premises servers to the cloud, so it would provide an easy migration path for moving existing applications to the cloud. For the test and development environment, for the storage, backup, and recovery. So we can quickly set up and dismantle test and development environments, bringing new applications to market faster. IaaS makes scaling development and testing environment fast and economical. So when we'll create the virtual machine, I'll show you how you can set up the scaling rules. If you remember, we talked about scaling up and scaling out, increasing the number of resources and the number of virtual machines for the particular application. So it's we can enable the auto scaling, or we can scale the virtual machines manually as well. And if you talk about storage, backup, and recovery, organizations avoid the capital outlay and complexity of storage management, which typically requires skilled staff to manage data and meet legal and compliance requirements. IaaS is useful for managing unpredictable demand and steadily growing storage needs. The infrastructure as a service can also simplify the planning and management of backup and recovery systems. Then we have platform as a service. Platform provides an environment for building, testing, and deploying software applications. The goal of PaaS is to help you create an application quickly without managing the underlying infrastructure. For example, when deploying a web application using PaaS model, we don't have to install an operating system. So if we are creating a web app, I would not build up a server, do the cabling, network switches, routing, LAN, WAN accelerators, nothing. I'll just use the PaaS model offered by Azure, which is Azure Web App or Azure SQL PaaS database as well. I'll just create the web app, and the underlying infrastructure storage is managed by the cloud provider, and I don't care about it. They are managed, updated, provisioned by the cloud provider at the back end. I would just care about my web app and do the deployment on it. And it is also the pay-as-you-go model, so I'll pay for what I'll use. And we can also enable the auto scaling, backup, recovery, raster recovery, dump analysis, profile troubleshooting, everything on the services offered on the PaaS model as well. And if you would see the scenarios, you have the development framework, analytics or business intelligence. So as I told you, you create apps because the PaaS model would provide you a framework that the developer can use to build, develop or customize the cloud-based applications. It's just like the Microsoft Excel macro. The PaaS lets developers create applications using built-in software components. Cloud features such as scalability, high availability, and multi-tenant capability are included. And if you would talk about the analytics of business intelligence, tools provided as a service with PaaS allow organizations to analyze and mine their data. They can find insights and patterns and predict outcomes to improve business decisions such as forecasting, product design, and investment returns. Now we have software as a service. SaaS is software that is centrally hosted and managed for the end customer. It is usually based on an architecture where one version of the application is used for all customers and licensed through a monthly or annual subscription. We have Office 365, Skype, Dynamic CRM, Online are perfect example of SaaS software. So if you would talk about the cost and ownership associated with these three different models. So if you would see the upfront cost, there are no upfront cost in IaaS, and the user is responsible for the purchase, installation, configuration, and management of the application in the IaaS. Cloud provider ownership, the cloud provider is responsible for ensuring that underlying cloud infrastructure such as machines, networking is available. And if you would see the PaaS, the upfront cost, there are no upfront cost in PaaS as well. Ownership is handled on user for the development of their applications, but at the backend storage would be taken care by the cloud provider. And the cloud provider ownership, the cloud provider is responsible for operating system management, network, service configuration in the PaaS. And if you would see the SaaS model, users have no upfront cost. They pay a subscription typically on a monthly or annual basis. Users just use the application software. They are not responsible for any maintenance. And the cloud provider is responsible for the provision, management, and maintenance of the application software. And if you would talk about the management responsibilities, the one thing to understand is that these categories are layers on top of each other. For example, PaaS adds a layer on top of IaaS by providing a level of abstraction. The abstraction has the benefit of hiding the details that you may not care about, so that you can get to coding quickly. You don't have to worry about configuring the application, setting up the server, etc. You just have to worry about deploying your applications and working on it to enhance it. However, one aspect of the abstraction is that you have less control over the underlying hardware. The following illustrations show the list of resources. So if you would see the scenarios in which as a user you manage and the cloud provider manage. So on the on-premises, you manage everything from applications, data, runtime, middleware, operating system, virtualization, servers, storage, and networking. When it comes to infrastructure as a service, applications, data, runtime, middleware, operating system is managed by you, but the virtualization, server, storage, networking is taken care by the cloud provider. And now if you will look at the platform as a service, the applications and the data is managed by you as a user, but the runtime, middleware, OS, virtualization, server, storage, and networking is managed completely by the cloud provider. In the SaaS, everything is managed by the cloud provider. So the Office 365, Dynamic CRM, we just use it. Office 365 we use as an application. Outlook 365, I don't have to worry about patching, updating, maintaining of the application. So as you see the differences in the on-premises, IaaS, PaaS, and SaaS, you would understand at what level you need to manage and at what level provider has to manage. So as you saw, IaaS requires the most user management, PaaS requires the less user management, and the SaaS requires the least amount of management. The cloud provider is responsible for managing everything, and the end user just uses the software. So there is a knowledge check for you guys. So Let's see, which term for the list below would be viewed as benefits for using cloud services? Unpredictable cost, elasticity, or local reach only? I give a pause for 10 seconds and I would let you guys write your answer on a piece of paper, or on, if you don't have a piece of paper, write it on in your phone. Which term from the list below would be viewed as benefits of using cloud services? I hope you have wrote down your answer. Now the second question, suppose you have two types of applications: legacy applications that require specialized mainframe hardware and newer applications that can run on commodity hardware. Which cloud deployment model would be best for you? Would you go for public cloud, private cloud, or hybrid cloud? I give you 10 seconds to note down your answer. Alright, next question. You are developing an application and want to focus on building, testing, and deploying. You don't want to worry about managing the underlying hardware or software. Which cloud service type is best for you? Would you go for infrastructure as a service? Would you go for platform as a service? Or would you go for software as a service? I'll give you 10 seconds again. Alright, I hope you have noted down your answer. Let's match it. If you have selected elasticity for the first question, you are right. And if you have selected hybrid cloud for the second question, you are right. And if you have selected platform as a service for the third question, that you were right. And if you are wrong, please go through these videos again. And if you have any queries, mention them in the comment section. So, summary: in this session, we have learned about cloud computing, what it is and what its key characteristics are. Here are some of the things that we have covered. We have covered different types of cloud models that are available. We have gone through some of the key terms and concepts such as high availability, agility, elasticity, fault tolerance, and CAPEX versus OPEX. CAPEX is capital expenditure, OPEX is operational expenditure. The different cloud services available, the benefits of using the different types, the management responsibilities. We discussed about cloud models such as public, private, and hybrid, and what the key characteristics of each model are. The different types of cloud services available, as SaaS, what the key characteristics of each service are, and when you would choose one over the other. Now, before we move further, I just want to give you the kind of services that we'll see on the cloud provider portal when I'll show you the Azure portal. You would see compute for the VMs and containers. You would see database for the relational and NoSQL choices. You would see the identity services that help us to authenticate and protect our users. We would see the networking services that connect the data center to the cloud, provides high availability, and hosts the DNS domain. You would also go through storage solutions that can accommodate massive amounts of both structured and unstructured data. We'd use it for AI and machine learning to build services that can analyze data, text, images, comprehend speech, and make the predictions using data, changing the world of architecture, healthcare, and much more. And the cloud is associated with many more things, like the crypto mining is also done on the cloud resources. If you are interested, please go ahead. And this was the end of what we have covered so far. I hope you liked these two sessions of the basis of cloud computing. We'll cover more in the coming videos. I hope your answers were also correct. I wish you best of the luck, and I'll see you guys in the next video. Thank you.